Okay, this is 10.2, identifying and creating a reflection. So reflection is also a translation, okay, or a transformation. And basically, think of what the word reflection means in your everyday life. If you were to look in a mirror, you see a reflection. So basically, it's just a mirror image of what you see. Okay, so circle the correct word or phrase to complete each sentence. When you reflect a shape, you slide it, flip it, or turn it. Well, all we're doing is we're flipping it because a reflection is just a flip. Okay? It's an opposite image. When you reflect a shape once, the image will face the same way as or a different way from the original shape. When you reflect a shape, the image will face a different way. It's going to face the opposite. So when you look, you're looking into a mirror, but your mirror image is looking out of the mirror, okay, back at you. So that's a different way from you. Paper airplanes are symmetrical. Jason drew half of this wing design. How can you finish the design to make it symmetrical? Okay, well, here's what we do. One way you can do, or understanding the word symmetrical, is it's just a way of describing a shape that can be folded along at least one line so that half of it fits over the other. Okay? So what are the coordinates of point D? So let's go to point D. The coordinates are x is 5 and y is 1. So 5 and 1. Draw a reflection of D across the y-axis. This is the important thing, across the y-axis. Here's our y-axis. We want to go across it. What are the coordinates of D primes? We want to go, pretend that this y-axis is the mirror. Okay, so from where the object starts right here, how far is D away from the mirror? Well, it's 1, 2, 3, 4, 5 away, and it's 1 up. So we're going to go 5 away this way. 1, 2, 3, 4, 5. But we're going to be on the same y-axis. So this is D prime. Okay, so what are its new coordinates? Well, they're -5 and +1. Okay, notice how the y-axis did not change, but the x-axis changed by 10. Okay, it's the opposite number. How did the coordinates change when reflected point D across the axis? Well, the x changed and the y did not. Did not change. Why does it make sense that points A and E won't move when you reflect them across the y-axis? This is point A and this is point E. Well, because they become the mirror image of the object across the axis. That's why they won't move. They're actually on the axis. Okay, they won't move across because they are on the axis. On the axis and actually touching it. So if it's sitting on the axis, it's like having your nose pressed against the mirror. Okay? Reflect points B and C across the y-axis. Connect all the points to finish Jason's drawing. What happens to the coordinates of a point when reflected across the y-axis? Okay, so A is going to stay there. There'll be A prime, and then B is going to be right here. And then C is going to be right here. Okay, so we can connect these points here, there, connect it down there. We can connect it here. Use your ruler, get a better drawing than I will. There and there. We'll label this. This now becomes C prime. This was D prime. This is B prime. And this point is A and A prime and E and E prime. Okay? What happens to the coordinates of a point when you reflect it across the y-axis? Well, they become the mirror image of the object. Across the axis. Okay? The image of triangle ABC was made with a single reflection. Determine the line of reflection. Now I want you to notice something. Its reflection, it's in the same grid. It's in the same bottom corner here. It hasn't reflected across the x-axis. It hasn't reflected across the y-axis. Okay, so that's going to change things up a bit. It's reflected inside this quadrant right here of the grid. So let's determine the line of reflection. Two ways you can do this. You can copy and fold it. So you can get some tracing paper. You can put tracing paper over here. You can trace each object out, and then what you can do is you can fold it so that this image, when you fold it, lines up exactly over this one, and then that line, that crease, is going to be your line of reflection. Okay? Now what if you don't have tracing paper? What do? Well, one way we can do it is just write down the coordinates so we can complete the chart here. So the vertices of ABC, well, A is 2 and -4. B is 5 and -1. And C is 5 and -4. And A prime is 7 and -9. B prime is 10 and -6. And C prime is 7 and -6. Now because they're in the same coordinate, they haven't crossed any axis, the x or the y, you'll notice that we can't use the rule that we kind of used over here on this one, okay, where we crossed over the y-axis, the x coordinates or the y coordinates remain the same. Okay, we can't use that rule because it's within the same quadrant. Okay, so what does that mean for us? Why didn't any vertex coordinates change to their opposites when ABC was reflected? Like if you remember from the previous one, it was the opposite. The y coordinate stayed the same. The x coordinates just went to the opposite number. It's because they're in the same quadrant. So the reflection is in the same quadrant as the original image. Okay, hasn't crossed over a line of an axis. Draw a straight line to join each vertex on triangle ABC to the corresponding vertex on triangle A prime, B prime, C prime. What do you notice about the connecting lines? Okay, so let's connect them here. So we'll connect them there. We'll connect them there. And we'll connect them there. What do we notice about them? Well, these lines here, what are they? Well, they're all parallel to each other. Okay? They are parallel. That symbol means parallel to each other. Use a ruler to locate the midpoint of each connecting line. Join the midpoints with a straight line. What do you notice? So let's get a ruler. Join the midpoint. One midpoint's there. I'd say one midpoint is probably right there. And the other midpoint is probably right there. And then we can connect them with a ruler here. Okay. What do you notice about all three of those points? Well, they line up together. Okay. And then, what do you notice about the angle formed where the lines of reflection meet each connecting line? Well, they form a right angle. They form a right angle. Okay, so this is kind of an odd one, but it's a reflection within the quadrant. It hasn't crossed over the x-axis, hasn't crossed over the y-axis, so it's not like it's a mirror image, but it's not like a mirror image across an axis. It's within the same quadrant. Okay, so it's kind of a special situation, but most of the reflections you're going to do will be across an axis. Okay, most of the practice that you'll do. Okay, so go ahead and start the practice.